You like the last one so much, why don't we do another one? Here we go, another ocean port. Here we go. We've got another, oh my goodness, we got another tidal thing here. Yes, the tides, the depth of the water in meters at a certain time. But look at this formula. This is just, it's revolting, isn't it? Yeah, I know, I agree. But so what? Not every port in the world is going to follow the same simple formula. The last question, we did an incredibly simple formula. This one has a little bit more, get ready for this, depth to it. Get it? Depth to, okay, fine. I thought it was hilarious. But anyways, so it says figure out here, estimate to the nearest tenth of a meter, the the time at 4:15, what is the depth at 4:15? And that's kind of important because if you're one of those people who are like a seagoing captain here on his vessel, he wants to know, is my vessel going to bottom out in this ocean, in this harbor or not? Okay, so it's really, really important to know what the depths are so that when you drive into this, you're not going to run into problems. Okay, so how are we going to do this? What are we going to do? Real simple, folks. Let's graph it. Before we graph it, though, maybe we should set this up a little bit. Notice that, yeah, look at this. My depth here, my D value, my average in here is 3.40 meters. Aha. Okay. So that means, oh, there's my amplitude. I'm going to add 2.1 meters to this. So 3.40 plus 2.10 meters, give me 0. That's going to be a 5. That's going to be 5.50 meters. That's my maximum, 5.50 meters. And that's going to determine whether or not my ship will be even allowed to port there because of the fact that if it doesn't get deep enough, why risk it? Now, what's the minimum as well? Okay, real simple. Take the 3.4. There's your D value. Subtract the 2.10. That's 0. That's 3. That, of course, is 1.30 meters. So down here, look what I'm doing, 1.30 meters. What I'm doing here is I'm setting up the box. You betcha. I'm setting up the box and I'm finding out what is going to be my Y min, my Y max, and so on and so forth. Now, also check this out. I'm going from time of 0, which is midnight. That's 12 o'clock in the morning. That's midnight. To, guess what? I want to know what it is for the whole day. So this is 24 hours. Oh, how sweet. Look at that. I got my window settings all ready to go. So let's take this, put this on our calculator now, and start right away with our window settings. Our window, of course, our X, which is our time, is going to be 0 to 24 hours. That's already in there from the last question. I'm going to go up a scale by 1. But what's my minimum? What's my maximum? My minimum, if you remember, it was 1.30. My maximum worked out to be 5.50. So this particular graph is going to max out the entire area. It's going to go from the bottom all the way to the top. Beautiful. Okay, good enough, Ski. Let's go and put the equation in. This is where the fun starts. Okay, I'm going to go back to here. Do yourself a favor. You got a piece of paper right now and a pen? Write down this equation because it's a monster. And not knowing how to put this in properly and flipping back and forth. I don't want to go flip back and forth in this podcast between this and the calculator. I just want to go out and do it. So write down this equation right now and let's go through it step by step, okay? And how to do this properly. Okay, ready? Okay, y equals 2. So if you look at this, this was 210, 2.10, okay? This was going to be a sine function. Now you got to put your 2 pi, but look what happens as soon as you put in the sign. That automatically puts this craziness there of a bracket. Okay, fine. 2 pi, but now you're going to get some sort of fraction. Okay, that's that fraction of t minus 3.25 over 12.40. Okay, so why don't we just put in the fraction right now? But what I'm going to do is I like to keep this fraction isolated. So I'm going to put it as a bracket. So now I'm going to put my fraction in. All right, alpha fraction. Beautiful. Okay, there's my x because I don't have t. So x minus 3.25. Right? On the bottom here, I'm going to put my 12.40. Now, get out of this. Put a bracket around that. That's that portion. But I'm still not finished because this is what's going to catch you. You're not going to put all the brackets down. You got to put every single bracket down. You got to close this guy off here because that's the whole portion. It's this portion here that was under the sign. Because as soon as you go out past this, this is where your plus 3.4. There's your D value. That's where your D value is. Okay, it's outside of the sign. If you didn't put the brackets around it and forgot one of the brackets, that 3.4 value would be inside the sign and you would get this wrong. Oh my goodness. Okay, now that we got it, let's graph it. Oh, look at how pretty that is. Oh my, oh my, oh my. Beautiful. There's my graph. Now that I've got it in my calculator, now I can solve this. Back here. The question is, try to figure out what it is at 4:15. Okay, wait a second. Remember, this was a 24-hour clock. This was a 24-hour clock. So this went out to 24 hours. 4:15 is somewhere in the afternoon here. Because if you used 4:15 right into your calculator right now, number one, oh, this is 4:15. 15 is a time. You remember 15 is a quarter of an hour. Oh boy. Okay? And 4:15 in the PM means, I don't know, 4:15 in the morning is there, 4:15 in the PM is there. Okay, so what do? Real simple. You know you're going to go up to 12 o'clock here. You're just going to add 4:15 to this to give you, well, you can't add just 4:15. We'll take care of that. Let's add the 4 hours to this. So right now you're at 16 right there. But remember, this is 15 minutes. This is 4:15, 15 minutes. So convert that into hours. Real simple. 15 minutes, get rid of the minutes, put it on the bottom, put the hours on top. You know to divide that by 60. So if you divide 15 by 60, go to your calculator here. Let's do a quick calculation. 15 divided by 60, you worked out to be, just like we said before, it's a quarter of an hour, 0.25 of an hour. Okay, so this in fact is going to be 16.25. That's the time that you'll have to put into the calculator. But remember, this is 16.25 on this x-axis. So what are we after then? Oh, real simple. Let's go back to the graph. We are on the x-axis at 16.25, right? Okay, second calc. Let's find the value at 16.25. There's our x value. There's our time, 16.25. Boom. Answer is, oh, there's your depth, 4.02. Go back to the question. To the nearest tenth of a meter, this is going to be 4.0 meters at 4:15 in the afternoon. You got it? Pretty cool, right? Yeah, I know. Okay, let's keep on going then. Now, look what it says here. To the nearest tenth of a minute, to the nearest tenth of a minute, what time of the day, I know it says one time in the day, is the water 2.9 meters deep? Okay, same kind of question, but think about what the graph looks like. The graph looks like this right now, okay? You want to know when is this 2.9 meters. So you're going to be here. So you want to know what is 2.9 meters. And you're going to see some really cool things. You realize that this now is a y value. So go back to your calculator here. Let's clean this up. We need a y value, right? Okay? We need a y value. So let's figure out what that y value is. Okay. Oh, wait. There it goes. Figure out the y value by going down here and putting in the y value. You know that this has to be at a certain depth, which we figured out to be, what was it? 2.9 meters deep. So put down 2.9 meters. That's the depth. Because your equation talks about depth. You want to find 2.9 meters, throw it in there, graph it. And you find out, look at that. During the day, it's at 2.9 meters here, 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 and here. And my question is, to the nearest minute, okay, what tenth of a minute, actually, to the nearest tenth of a minute, what times are these? Okay, let's find the intersects. Second calc, let's find the first intersect. There it goes, 5. Mouse it over. Where are you? There it is. There's the first intersect. Dump, dump, dump. Okay, you're at 2.77. Well, what does that mean? Remember, second quit. 2.7, x equals 2, right? This is 2 o'clock in the morning, right? 0.77. What does that mean? Oh, okay, so get rid of the 2. Now you're dealing with 0.775 of an hour. Multiply this by 60 to tell you that this is at 2 o'clock, 2 o'clock 46, 2:46 in the morning, 0.5, because it wants it to the nearest tenth. So your answer is 246.5. 2 o'clock in the morning, 46.5. That's AM. Oh my goodness. Okay, that's pretty specific. Let's go to the next one. Let's find out another one, just for the sake of doing it, okay? Just for the sake of humoring me, shall we say. All right? Okay, let's go back to our graph. Let's find this guy right here. Let's find the other time that it's at that depth. Second calc, find me an intersect 5, but now we're going over to this guy. Check it out. Enter, enter, enter. We're at 9.924. Okay, what does that mean? Second quit, go x equals 2 again. There's the 9.9, so we're at 9 o'clock in the morning, but what does this 0.92 stuff stand for? Yeah, it's 0.92 of an hour. So get rid of the 9 o'clock because we know it's 9 o'clock. Let's multiply this by 60 and find out the minutes. So I got 9 o'clock, it's 9:55.5. 9:55.5 a.m. Let's keep on going. Let's do it for the whole day. Okay, so figure out the next one. Graph it. Same nonsense as before, but now I'm figuring out the afternoon times. And that's why I want to really do this, is to show you that, don't forget, you have to include that 24-hour clock. So you have to add it to 12. Okay, let's go. Second calc. Find the intersect. 5. On we go. Enter, enter, enter. Beautiful. Look at that. We're at 15.17. Okay. Same rule as before. Hit X, enter. There's your 15.17. So you're at 15 o'clock? What does 15 o'clock mean? Well, we'll get that in a second. Let's subtract the 15 off there because we know it's 15 o'clock. Multiply that by 60, and you got, oh, look at that, 10.5. So whatever 15 o'clock is, well, think about it. You're here from 1 to 12. 13 o'clock would be 1 o'clock. 14 o'clock would be 2 o'clock. 15 o'clock would be 3 o'clock. So you are at 3. What was our answer? 3 o'clock, 3:10.5. There it is. You're at 3:10.5 now in the PM, in the afternoon. We got one left to figure out. Woo! This is a long podcast. Sorry about that. Okay, here we go. Second calc, let's find the last one, intersect. So, here it is. Okay, enter, 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 and we're at, oh, look at that. That's now at 2.9. Oh, the intersection's at 22.3 at 2.9 meters. Okay, so what is 22.3? That's getting close to midnight because we're on a 24-hour clock, right? Okay, so back to this. Go x equals 2. There you go. So you know it's 22 plus the 0.23. So subtract the 22 from that. Figure out what that 22 o'clock is in a minute. There's 0.32 of an hour. Multiply that again by 60, giving you 19. So this is going to be whatever 22 is. Okay, so think about it. If midnight is 24, that's midnight, 12 o'clock midnight. Okay, 23 is got to be 11 o'clock. 22 is got to be 10 o'clock. Oh, beautiful. So we're at approximately 10 o'clock, just a little bit over. According to the calculator, it's 10:19 in the morning, 0.5, or in the evening, 0.5. 10:19, 10:19.5 in the evening. Look at that. That's how you do those 24-hour clocks. You got to do the 24-hour clock because there's no such thing. Your calculator does not recognize a regular 12-hour clock. That's what makes this question a little bit more challenging.